Okay, motion equations projected up. The variables we'll be using for this is v is the vertical velocity, a is the acceleration due to gravity, t is the time, v naught is the upward initial velocity. The equations we'll be using are v equals a times t plus v naught. The displacement of x equals t divided by 2 times v naught plus v, and the displacement of x equals v naught times t plus 1/2 times at squared. Some of the variable tips that you have to take in mind are that the acceleration is always going to be -10, and the velocity at its peak is always going to be 0. And also the speed is the same distance above ground. An example is a shoe is thrown up with an initial velocity of 40 ms. Calculate how long the shoe takes to hit the ground. So we know these variables to start off. So v naught equals 40, v equals -40, a equals -10, and we don't know t. We're trying to solve for t. So first off, what equation would you use to isolate one variable? So we know that we're going to have to use v equals a times t plus v naught, and then we just plug in the information, our known variables. So it's -40 equals -10t plus 40. Now we just solve. We solve for t, and we end up with 8s. So another question that could be asked for this type of problem is, how long does the shoe take to reach its peak? So we know now that the v is going to have to equal to 0 because of our other tip. So, and all the other variables stay the same. So we just plug that in. You plug it into the same equation, so it's 0 equals -10t plus 40. And we just solve it out, and we end up getting t equals 4 seconds. Finally, the last question is, how high does the shoe go? So for this one, we're going to have to use a different equation. So we're going to use the displacement of x equals t divided by 2 times v naught plus v. So here we just plug in all the information we know, and we just solve it out, and it equals 80. Okay.